In this lesson, we're going to be doing a quick survey of graphing lines. This is something that you would have learned in Algebra 1, so it's more of a review here as we come to Algebra 2. Here we have linear equations or functions. A linear equation in standard form is ax plus by equals c, where a, b, and c have to be real numbers. All linear equations except vertical lines can be written in function notation, and this function notation can be written f of x equals mx plus b. We learned that f of x really is the same as y, so f of x and y are interchangeable. Please notice that the b here in f of x equals mx plus b is not the same as this b. They're different numbers. So don't get those confused. They are not the same b. So what we're going to do, this first example, we're just going to take negative 3x plus 4y is equal to 12 and write that in function notation. Well, function notation is right here, and really we want y on the left side, which is our f of x, and everything else on the right side. So we're going to be solving for y. To do that, we can add 3x to both sides. Notice in my form the term with x comes first, so I'm going to do that. So we have 4y equals 3x plus 12, and then to get y by itself, I'm going to divide both sides by 4, and I'll do this in 2 steps here, but as we work through we won't have to do this because we'll realize what happens. 4 here is a common denominator of both of this whole thing, 3x plus 12. So we really can split this up. We can have 3/4 x plus 12/4, and we know 12/4 is 3. And so we can write this in function notation. Instead of writing the y, we can write f of x, or I'll use g of x, is 3/4 x plus 3. Noticing that this is our value for m, and this is our value for b when we talked about the m and the b here. So that's writing in function notation, and that's going to be very helpful. That notation or that form is going to be very helpful when we graph. Let's look something else about lines, and really all functions. We have what are called x-intercepts and y-intercepts. An x-intercept is where a graph, a line, or other functions, a line crosses the x-axis, and then y-intercepts are where a line crosses the y-axis. And so that's what the definition of those things are. Now, if you notice here, where if we cross the x-axis somewhere, wherever it might be here where we cross the x-axis, it might be over here, but notice this point here is -4, 0. This blue point here, was supposed to be at 3, 0, and anywhere on the x-axis the y value is going to be 0. So the way that we know, or we can know what the x-intercept is, we can plug y in for 0. Plug 0 in for y, and these shouldn't be question marks. To find the x-intercept, plug 0 in for y. To find the y-intercept, plug 0 in for x. So this says find the y-intercept of f of x equals 2/3 x minus 2. Well, to find the y-intercept, we plug in 0 for x. So here I put, really I'm just finding f of 0. I'm putting 0 in for x, so here's our x, we put 0 in there, minus 2. 2/3 times 0 is 0, minus 2 is -2. So the y-intercept is -2. In fact, it's the point 0, -2. But notice here, what can we conclude about the y-intercept of any line in the form f of x equals mx plus b? -2, and our y-intercept was -2. Because anytime we plug a 0 in here, no matter what the equation, this term will be 0, and then you'll have this term here. So b in that form is the y-intercept. And that's very helpful for graphing, because you'll always know where it crosses the y-axis. So find the y-intercept of 3x minus 7y equals 5. There's two ways we can do this because of what we just talked about. The first solution, the first way of doing this is just plugging 0 in for x and solving for y. So we can always, no matter what the type of function, to find a y-intercept, you can plug 0 in for x. So we would have 3 times 0 minus 7y equals 35. We know 3 times 0 is 0, so negative 7y equals 35. And dividing by negative 7, we get y equals negative 5. And so our y-intercept would be 0, negative 5. Another way is we could put this in solution 2, we could convert it to function notation. So we can solve for y here. We have 3x minus 7y equals 35. We can subtract 3x from both sides, which will give us negative 7y equals negative 3x plus 35. And dividing each term, both sides really, but each term by negative 7, we get y equals negative over negative is positive, so 3/7 x minus 5. And we notice here that our y-intercept is negative 5. And so we got the same thing, negative 5 and negative 5. This equation is going to be helpful later on because we can use that to graph. We're going to take another look at another part of lines, and that's steepness. So here I have lines A, B, C, D, E, F, and G. There's 7 lines there. Compare the steepness of the following lines. So A with B. Well, here we see B is steeper. The next one's C and D. C and D, C's not very steep, but it's still steeper than D, so D is steeper. What about B and E? Well, B is a pretty steep line, but E, you can't get any steeper than that, so actually in that one, E is steeper. Comparing A and C, well, actually they look like they're the same steepness, so they would be equal steepness. Comparing G and F, now those are a little different because both of those are going down. All the other ones that we looked at except E were going up left to right. They're going down left to right. There we see that G looks steeper. And then C and F. C and F looks like they have the same steepness. They're just going in different directions. So we're going to be looking at each of those things and putting a number to steepness because it's helpful if we can quantify it, because when we can put it to numbers, we know how to work with numbers mathematically, and that will help us. So here I still have all those different lines up there. But what we use to measure steepness, so we can describe or compare these different things, is we use what's called slope. And slope measures steepness. Slope really is, so looking at A, how far, so here's 2 points on here, how far you move vertically compared to how far you move horizontally. And so noticing maybe you go up 1 unit and over 2 units there. So that slope might be 1 over 2 because it's a vertical distance over a horizontal distance. A nice way to remember is rise over run. And then we have this equation here, which is the change. It's subtraction, so we can find a distance by subtracting. So a y value minus a y value, because they have to do with the vertical, over an x value minus an x value, because they have to do with the horizontal. So a couple things, some slope facts. By the way, this is a very, very, very important equation. We'll be using this later on. Some slope facts. A positive slope moves up from left to right. So looking at these lines at the top, I'm going to go ahead and put whether the slope is positive or negative. So this is moving up left to right, so this is a positive slope. This is really steep, it's moving up left to right. This one isn't moving up left to right or right to left or down left to right, it just stays the same. This one is just going straight up, not left or right, and these two are both going down. The next one, a negative slope, moves down left to right. We just mentioned that these two then would be negative. They're moving down left to right. So before, on the slide before, I mentioned that F and C look very much alike in their steepness. Well, now we know their number value might be the same, but one's going to be positive and one's going to be negative. Slope of 0 is a blank line. So let's look at these two, because we haven't mentioned these yet or put anything here. Remember, slope measures steepness. So what would have a slope of 0? What has no steepness at all? Well, that's this line right here. And so that's a horizontal line. An undefined slope, or really the ultimate steepness, you can't get any steeper than it, is a vertical line. And so those are important things to know about slopes. Positive slopes move up left to right, negative slopes down left to right. Slope of 0, which is a number, is a horizontal line. So, and then vertical line has undefined slope. So let's find the slope of these two lines. This is normally what will happen. We'll have to find slope in one of two ways. In this first one, we have a graph of a line. So for this one, it might just be helpful to find 2 points, 2 lattice points, as close as we can. So here is a lattice point. That's where it crosses a vertical and a horizontal. And then here's another one. So we can just use this idea here, that slope, which we use m to measure slope, is rise over run. So we can start at one point, go up 1, 2, 3. So the rise is 3 compared to the run 1, 2, 3, and 4. So we have a slope of 3/4. Now some of you might ask, well, what happens if I started at this point over here? So let's do this in red. So we want to go vertical first. Well, that's down 3, which is a -3, and then left 4. Well, -3 over -4 is still a positive 3/4. So it doesn't matter which one you choose first. So that's a way to have it, to find the slope when you graph it. Another way, you might be given 2 points. Now, if you forget the formula, you could always graph these 2 points and do something like this and count off the slope. But there's another way to do it, and it's this part of the equation right here. So this says that the slope is, here it says the first y value. Well, that's our 5. So 5 minus our second y value, which is -1. So be sure you put the minus and then the -1, and then our first x value. So this is -4 minus our second x value, which is 2. And then you can figure out what this is equal to. Let's put it here. 5 minus -1, that's really 6, over -4 minus 2, which is -6. And that reduces to -1. Now again, someone might say, well, what if you used the other point first? What happens if we use this as our first point? So let's check that. We've got m equals, and we can say our y value, so -1 minus 5, our second y value, over 2 minus -4. This is -1 minus 5, which is -6, and a 2 plus 4, which is 6, which still equals -1. So again, it doesn't matter which point you choose first. You'll still get -1. You must know this equation. Y sub 1 minus y sub 2 over x sub 1 minus x sub 2. That is the equation to find slope. And our last thing here is slope-intercept form. So don't get confused. If I ask for the equation of slope, That's y sub 1 minus y sub 2 over x sub 1 minus x sub 2. If I ask for slope-intercept form, that is y equals mx plus b, or you might see f of x equals mx plus b, where m stands for the slope and b is the y-intercept. So here, find the slope of 2x minus 3y equals 6. Well, if I look at this form, there's my slope right there. It's m. So if I can get my line here into this form, I'll know what m is. It's the 1 multiplied times x. So I'm going to go ahead and solve for y to get it in slope-intercept form. And we have negative 3y equals negative 2x plus 6. Dividing both sides, which is the same as dividing each term by negative 3, gives me y equals a negative divided by a negative is positive. And then this is minus 2. So find the slope to answer this question. Slope is the part that's multiplied times the x. So the slope here is 2/3. Added bonus, I can tell you that this is what? This is the y-intercept. But that's not part of the question. And then the last thing, and this is the application, or kind of putting it all together, we want to graph 3x plus 2y equals 6. We could do this in different ways, but usually the easiest way is to go ahead and get it in slope-intercept form. I want to get this in slope-intercept form, y equals mx plus b. So we will subtract 3x from both sides. We have 2y equals negative 3x plus 6. And we can divide by 2. And we get y equals negative 3/2 x plus 6 divided by 2 is 3. Now we want to graph this. So when we graph a line in slope-intercept form, this is key. What we do is we start with 3. That is our y-intercept. So we're going to go ahead and graph 3 on the y-axis. Not the x-axis, but the y-axis. So we have our y-intercept, and now we're going to use the slope here of negative 3/2 to help us find some other points on our line. So we know, I'll go ahead and write it down here, slope is negative 3/2. Now we have a negative out here. That means we could write it as negative 3 over 2 or 3 over negative 2. And we'll use both of those as we go through here. So let's use the fact that it's negative 3 over 2. That means from this point our rise is negative 3, so go down 3, and then positive 2, which is right 2. That would give me this point. And I could keep doing that, down 3, right 2, down 3, right 2. I also could use this. This actually says we'll go up 3 and then left 2. So up 3 and left 2. So using either one of these ideas of negative 3/2 is going to give us what we need. And then we can go ahead and graph our line through these points. And there's the graph of our line, which was 3x plus 2y equals 6. We wrote it in this more helpful form of y equals negative 3/2 x plus 3. And so that is a quick summary